Hello. In this module, or rather in this video, we're going to talk about a administrative control called a job safety analysis or job hazard analysis, JHA, JSA. But I'm going to just call it a JSA, job safety analysis. It's a really good idea. And we're going to go over it, and then there's going to be and you're going to see a thing OSHA included in here in this PowerPoint. What the little scenario that they set up to do a very simple job safety analysis, but you get the idea, I hope. And so without further blabbing, let's get this started. Okay. Job safety analysis, JSA, JHA, job analysis. And like I said, we'll just call it a JSA, job safety analysis. Okay? First, calculate the risk as shown on the next slide. Now, pay attention, this is important. Okay, that's how you calculate the risk, first of all. So you got that? Good, because there'll be a test later. I'm just kidding you now. Okay, what's a job safety analysis? It's a technique that focuses on job tasks as a way to identify hazards before they occur. It focuses on the relationship between the worker, the task, the tools, and the work environment. Ideally, after you identify uncontrolled hazards, you will take steps to eliminate or reduce them to an acceptable risk level. Kind of what this is all about, isn't it? So the job safety analysis is going to break the job down into individual steps. That's what you do first of all. Just a three-step process. That's pretty simple. And once you look at each individual step, you want to identify existing and potential hazards in that step, not just things that you know, but things that might happen too. And then you want to go through the hierarchy controls and what controls can we use to minimize the hazards or the risks, minimize the risk from the hazards that you've identified. So where to start? Well, it's a good idea to involve the employees. They usually know more about what's going on than anybody. In fact, they always do. The employee doing that job knows more about that job than anybody. All right. Review the accident history too. Again, anytime you hear me talking about accident history, I always fall back on two main things: OSHA logs, workers' compensation claims. That's the thing about OSHA logs is they're about as accurate of information as you're going to get if you've done them properly, and you're going to follow a specific set of rules for the accidents to be listed on there, as you already know. And workers' compensation claims pretty much follow the same. Sometimes the workers' compensation claims, though, can be, you wouldn't realize that the accident didn't look that serious, and you find that it's a $40,000 claim. You think, how'd that happen? So you might want to. That's one of the reasons why the workers' compensation claims is good too. Preliminary review: talk to supervisors and employees about how to eliminate and control hazards. Just talk to people. I think you can do that. And then you want to list the priorities. Job with the high risks. Again, that's where you'll get this from the analysis you've done. If you look at the OSHA log and you find out that you've had 12 injuries in this department and 4 of them were on machine 2, well, maybe you want to look at machine 2 to see what's going on there. And also jobs with more severe consequences. When you find out that, gee, the risk here is, you might get 2 stitches in your finger. The risk over here is you might lose your arm. So that's also, you'll look at that too. So let's see, break the job down into steps or tasks. Observe the job being done, of course. And this is sometimes a difficult part of this thing. Not too broad or not too detailed either. So you can't have a step that's huge, but you can't have a step that's, that's too small either. So that could be a little tricky to do. Get input from the operator and others performing the same job, by all means. Review with the employee to be sure nothing has been omitted. Make sure you've got it down. You go with the employee. Now, these are the steps you follow, right? Boom, boom, boom. Let them know. And then record them in their normal order of occurrence. Most jobs, except there's some jobs like, for instance, maintenance, even though they have some jobs in there that occur over and over again, like you're changing a motor or something like that. But a lot of maintenance activities aren't real, are the same all the time. But in production, yeah, a lot of times they're pretty much the same. So record them in a normal order of occurrence. Identify the hazards. Hazard something has the potential for harm, or what possibly could go wrong too. Remember, if everything goes right, then you don't have a problem. But things do go wrong. And one thing you want to look out for is to think about, or what could happen if something does go wrong? What are the consequences? How could that happen? Are there contributing factors? How likely is it the hazard will occur? These are things you need to think about. For instance, hazards, you've got chemicals, you've got toxic chemicals, flammable chemicals, corrosive, explosion. Electrical, you have shock, fire, static discharge can happen. You have slips, trips, and falls from elevation, from one height to another, tripping on something, slipping on something on the floor. Fire, heat, it burns, heat exhaustion, heat stroke, noise above 85 decibels, any time limit average. What's that called? That's the action level. We'll talk about that in a couple of modules. Struck against, contact against something by a body part. You hit yourself against something. Weather could be hot, cold, could be snow, rain, or ice. There's jobs where that's a factor. Mechanical, there's a lot of things are mechanical. In-running nip points. You got a piece of equipment that has in-running nip points. Is that a hazard? Yeah, it's a big hazard. Caught between the moving parts, you get caught in between them. Anything moving equipment is by definition a hazard. I mean, something moving, something just sitting there is probably not going to hurt you, but if it's moving, it's good. Gears and sprockets, belts and pulleys are very similar. They have in-running nip points, nasty, and they can be really, really bad. Abrasion from moving or turning parts can be a hazard. Sharp edges, burrs, sharp objects, knives, etc. Visibility could be a problem. Lack of sufficient lighting, obstructed vision. So we just talked about a bunch of hazards, and I know you heard some of them before, but that's okay. You can't remember and learn everything by hearing it one time. So throughout this course, you're probably going to hear, and we covered so many things, you're going to hear a lot of these same things over and over again, and that's okay. So far now what we've done is identified each job steps and identified hazards associated with each job step. The next step is determine how to control those hazards. Ta-da! There you go. The infamous hierarchy of controls. Elimination, physically remove the hazard. Substitution, replace the hazard. Engineering controls, isolate people from the hazard. Administrative controls, change the way people work. And PPE, the last line of defense, protect the worker with PPE. So again, elimination, the short version or the short definition of elimination is physically remove the hazard. It's good that you know that too. Best done in the planning and development stage. It's harder to do when something's already up and running and going to eliminate it. Substitution, replace the hazard. Use a less hazardous substance or operation, and that's frequently used in chemicals. You could do other things too, but you could have something that's a higher degree, let's say of electricity, a higher voltage, and you can have something that's lower voltage, and that would be something different. That would be a substitution. Engineering, isolate people from the hazard. That's what, in a nutshell, engineering does. Isolates people from the hazard. You have guards, enclosures, interlocks, light curtains, local and exhaust ventilation too. Guards being the number one on that hit parade. Administrative controls change the way people work. That's what they do. Most common of these is training, but you also have operating procedures, JSAs, that's what we're talking about here, job rotation, alarms, signs, warnings, and personal protective equipment, PPE. Protect the worker with PPE. That is your last line of defense in the hierarchy of controls. Eye protection, hard hats, hearing protection, safety shoes, etc. A lot of PPE out there. The biggest problem with PPE is it requires people to use it. So after the JSA is completed, what do you do with it? What do you do with it? Well, you want to let current employees go over it to be sure it covers everything, and use it to train employees new to the job too. So how often should JSAs be reviewed? Well, there's no set thing, but it's a good idea to review things annually. Review if there are any changes to the job or workflow. Of course, again, anytime you talk about training in OSHA, that's one of the things. If there's changes, there's probably going to be, they need training to happen. If there's an injury, illness, or close call occurs on the job, you might want to look at it then, because what went wrong? Was the JSA not good enough? We didn't handle the situation. So here's an example, and this is right out of OSHA here. Employee picks up a 15-pound casting, grinds off any burrs, and places it in a box. So that's pretty simple. You pick it up over here, doing something to it, and putting it down over here. Now you can see from that picture, this is just the way people come to work all the time, right? That's the kind of clothing they wear, and this picture is pretty old, but it's OSHA, so they're not prone to updating stuff that they don't think needs to be updated. But that's simple. On the first picture one, he's picking up that thing. The second one, he's grinding it. The third one, he's putting it away. Sounds pretty simple, doesn't it? So job step number one, reach in the metal box to by the machine, grasp the casting and carry it to the grinding wheel. Okay. Number two, push the casting against the wheel to grind off the burrs. Number three, place the finished casting in the box to the left of the machine. Pretty simple, right? So take one, the job step one, take the task description would be worker reaches in the metal box to right a machine, grasps the 15-pound casting and carries it to the grinding wheel. So the hazards, well, he could drop the casting on his foot, 15 pounds falling from 3 feet high or so on your foot. You can do some damage, right? So controls, okay. Oops, okay. Step one, you could drop it on his foot. So the controls, wear safety shoes with arch protection on them. Wear protective gloves for a better grip. There's two things you could do than that. You can wear shoes so you don't drop it, and you can wear some gloves on to have a better grip on it. One thing that gloves do a lot of times, especially if they're designed to do that, is to help you with the grip. So job two, task description, push the casting against the wheel to grind off the burrs. So the hazards, castings could have sharp burrs. It could cause a laceration, right? So wear cut-resistant gloves and fit tight so they don't get caught in the grinding wheel. Or use a device such as a clamp to handle castings. Job three, task description, place finished casting in box to left of machine. Three, hazards, reaching, twisting, and lowering 15-pound casting in the box could result in a back strain. So the controls, place the castings on an adjustable table or platform. Train workers in proper lifting techniques to minimize twisting during lifts. Training people in lifting techniques is good and it should be done. But you know what? When push comes to shove, boy, they hardly ever follow it. So, but okay, one thing that they can lift out of here was this is in the second one, grinding it off. Wouldn't you think that one of the things with grinding, anytime grinding, would be sparks or fragments in the eye? So you'd have eye protection. But this is pretty old. Maybe they didn't have eye protection back then. I'm not sure they did. Anyhow, this is the job safety analysis training guide. It's just not a job safety analysis per se, and it's got little stuff on it. But what it says is job steps. Break down the job into its basic steps. One first, and says observe the job, discussing with the operator, drawing on your knowledge in combination of three, and then potential hazards. Again, you observe it, to talk to it, and ask yourself, can he or she be struck by a contact anything? Could they strike against or come into contact with anything? Could the employee be caught in, on, or between anything? Could they fall, be overexerted, be exposed to anything injurious such as gas, radiation, welding, rays, etc., for example, acid burns, fumes. And step three is recommended safe job procedures. So be sure to describe specifically the provided safeguards and precautions an employee must use. Don't leave out important details. Number each separate recommended precaution with the same number you gave the potential accidents so that the precaution seeks the void. Use simple do or don't statements to explain recommended precautions as if you're talking to the employee. So, and avoid generalizing. Just be careful, be alert, take caution, etc. Those really aren't in the hierarchy of controls. So let's look at some actual JSAs here. Okay, these are bales of fiber. These are taken in a warehouse in California. Now these bands have now been changed to plastic, but they were metal bands at one time. And they're on there. You can see that they're under a lot of tension. See how tight they're pulling this. So the problem is when in the fiber processing plant, every one of these bales need to be opened up and the fiber pulled out and processed. So the bands on these bales need to be cut, removed, and discarded safely. The bands especially the metal ones, but there's plastic ones too. When you cut them, they pop out. So the first job step is to cut the bail bands. The hazards are hand laceration or the strap hand hits you in the eye. And it has. So the safe job procedures, wear leather gloves and wear eye protection. And then the second step is pretty simple. You remove the straps from the bail and you put them in a trash, because if you don't remove them and lay them on the floor. So again, now you have the same thing, hand laceration, because when you cut it like that, it has a sharp end on it. Strap end in the eye again, because these are big. These are long. These bands, when they're cut, they're long and they're tough to handle, and they want to do their own thing. Trip on the straps on the floor. If you put them on the floor, someone's going to trip on them. So safe job procedures there are the same thing as the first time. Wear leather gloves and wear eye protection, but also dispose of immediately. That's pretty simple there. You have a box there, just use an old box or something they had, and put them in that box, get rid of them right away. Don't lay them on the floor. And that's pretty simple. And this is one from NASA. You'd think that would be not real simple. You're right. Check oxygen monitor, oxygen deficiency due to malfunctioning monitors, number one. Ensure oxygen monitor is operating properly prior to bringing LN2 cylinder to the lab. Now, okay, I don't like that one, because insurance is, well, how do you do that? Why don't you say there should be some kind of standard check you do? Turn the oxygen monitor on, turn it and see if it's registering at 19.7% or whatever. The other 19.5, the ambient air is. So just ensure it's working right. That is weak. Inspect LN2 cylinder at dock, oxygen deficiency or frostbite. Check cylinder for damage, leaky valve or faulty gauge. Okay, ensure cylinder is appropriate size. Use proper cryogenic-proof gloves and chemical splash goggles throughout the process. All right, that's not too bad. The next three, cart liquid and nitrogen, which is LN, to the room. Place liquid or nitrogen tank close enough to the NMR, whatever that is. Place cart outside of the room. So the hazard or potential for mishaps, improper weight distribution may cause the loss of control of the cylinder cart and cause physical injury, and then injury, strain, or sprain due to improper material handling. So the protective measures, a good working cylinder cart and an able body to carry the large cylinder to the cart. Use the freight elevator. I think that's kind of weak too. A good working cylinder cart. Okay, how about inspect the cylinder cart for damage or something? Make sure it's in operating in order. An able body to carry the large cylinder on the cart. That's not really a good one either. I would have something you place it on. It can help if you need it. If the cart's if it's too heavy, or I'm sure there's a way to handle that safely. Use the freight elevator. Okay, I don't know where that's coming in at. Secure LN2 cylinder in lab. The hazard is blocked egress due to movement in an earthquake. That's a stretch, isn't it? Position cylinder in a designated area. Secure seismic restraints. It's a cylinder under pressure, so it should be restrained. This is probably in California. I don't know where it's at. Should you have some seismic restraints and things? Sure, if the hazard there is significant enough. But usually seismic restraints aren't that big, because an earthquake doesn't really have that much of a effect on the restraint. So it's just a regular restraint that's going to contain it pretty easily. But connect the thread end of the transfer tube to the liquid valve on the cylinder. The transfer tube needs to be attached smoothly so it does not damage the valve. Oxygen deficiency due to leaky fitting. And their preventive measures are additional help should be requested to hold up the transfer tube while attaching to the cylinder. That's weak too, should be. Okay, that's not the way you do it. You need to say you need to have two people do it, or you need to do it by doing this, or you have a tool or something that will straighten it out. But you don't have something like that. Should be requested. Do a leak check, okay? Do not over tighten, use designated tools. How about do not over tighten? How about torque to 37 foot-pounds or something like that? And then do the leak check after that. That's what I would do. So there, NASA, in my opinion, didn't do that great a job. This is for a press brake. We're going to go through this pretty quick. Part one, turn on a press brake. Parts, tools, potential hazards, tools, debris, electric shock, inside, outside press brake, floor area, flying pieces, slip, trip, and fall. Recommended safe job procedures, good housekeeping, check areas clear of tools, parts, debris, check flex cords for damaged and exposed wiring, wear PPE. Okay, now, and here at the top, they show you a line at the top that says required PPE, heavy gloves, Kevlar sleeves, safety glasses with side shields, heavy work boot, steel toe optional. And that's not any good. Heavy work boot. It shouldn't be that general. It should, should be steel safety toe shoes. So you can see that some of these aren't all that, in my opinion. I'm going to sneeze. Excuse me. Look at number 4, cut banding. Sharp edges and release of coiled energy, kind of like we talked about in the first one. Laceration, hands, arms, face. They're recommended safe job procedures. Now, the hazard is lacerations, hands, arm, face, and eyes. And their job tools use proper cutting tool. Now, does that make any sense at all? No. Okay. Well, they have safety glasses, side shields, and gloves on already up at the top. So I guess that's not too bad. But I don't know how the proper cutting tool is going to make a difference. But, all right. Anyhow, get the idea. And that's just a blank form there. Sequences. And that's a kind of a simpler form. And at the, okay, there is an assignment you're going to get in this about job safety analysis. I think there's 6 simple scenarios, and I've used these in prior classes, in-person classes. And I found out that I gave a brief description, and I found out the students spent most of the time just figuring out the steps. So what I did in each one of these, I just said the job steps. You'll already have that on the assignment because just to make it simple. And they're pretty simple. They're no more than, they're like from 3 to 5 steps. And then the next 2 columns, the first column, of course, is identify whatever hazards might be involved with that step. And then the last column is what controls will you use to control those hazards. And so do those, all 6 scenarios, and get them back to me, attach them back as a attachment to the file, or however you send them back to me. So hope you learned something about job safety analysis. I think the simpler you keep them, the better off you are, but you also have to be specific when it comes to PPE and what you want people to do, not like, oh, check something. Don't try to be wishy-washy on these things. So, all right, job safety analysis are great tools. So that's it from my ugly kisser in front of you for a while. So do the job safety analysis assignment and be safe.